Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Understanding Human Bias in AI Design. Understanding human bias in AI design is a critical aspect of developing human-centered AI systems that are fair, ethical, and effective. Human biases are cognitive shortcuts that can lead to systematic deviations from rationality or fairness, and these biases can inadvertently be embedded into AI systems, which in turn can perpetuate or even amplify them. This is especially concerning given the increasing reliance on AI in various sectors such as healthcare, criminal justice, and finance. To design AI systems that synergize effectively with human teams, it is essential to understand the nature of these biases and how they can manifest in AI systems. Human biases stem from various cognitive processes that simplify decision-making. These processes, while efficient, can lead to errors in judgment. Key examples include confirmation bias, where individuals favor information that confirms their pre-existing beliefs, and anchoring bias, where people rely too heavily on the first piece of information encountered. These biases can be transferred into AI systems through the data used to train them, the algorithms chosen, or the objectives set by the designers. For instance, a study by Obermeyer et al. Highlighted that an algorithm used in healthcare settings exhibited racial bias because it was trained on data that reflected existing racial disparities in healthcare access. This led to unequal treatment recommendations, demonstrating how biased data can lead to biased outcomes. The design process of AI systems often involves multiple decision points where bias can be introduced. Data collection is one such point. If the data used to train AI models is not representative of the population it will serve, the model's predictions will likely be biased. For example, facial recognition technologies have been shown to have higher error rates for people of color compared to white individuals. This discrepancy is largely due to the overrepresentation of white faces in the training datasets. This kind of bias, known as dataset bias, highlights the importance of ensuring diversity and representativeness in the data used for training AI systems. Algorithmic bias is another form of bias that arises from the design of the algorithms themselves. Some algorithms may inadvertently favor certain groups over others if not carefully calibrated. This can occur through the selection of inappropriate objective functions that do not align with ethical standards or through the use of biased feature selection. An example of this is the COMPASS algorithm used to predict recidivism rates, which was found to be biased against African American defendants due to the way risk factors were weighted. Such instances underscore the necessity for transparency and accountability in the design and deployment of AI systems. The issue of bias in AI is compounded by the lack of diversity in the field of AI design and development. A homogeneous group of designers is more likely to overlook biases that do not affect them personally. This is supported by research showing that diverse teams are more likely to identify and mitigate bias in AI systems. Therefore, fostering diversity within AI teams is not only a matter of social justice, but also essential for creating fair and effective AI systems. Mitigating bias in AI design requires a multifaceted approach. One strategy is the implementation of fairness-aware algorithms, which incorporate fairness constraints into the model training process. These algorithms aim to ensure that the model's predictions are equitable across different demographic groups. For instance, employing techniques such as reweighting or resampling of the training data can help balance the representation of different groups, thus reducing bias. Additionally, ongoing monitoring and auditing of AI systems are crucial to detect and address biases that may arise during deployment. Another strategy is to enhance the interpretability and explainability of AI systems. Black box models, which are often difficult to interpret, can obscure the sources of bias and make it challenging to address them. By developing interpretable models, designers can better understand how decisions are made and identify potential biases. Explainable AI can also improve trust and accountability, as stakeholders can scrutinize the decision-making process and hold designers accountable for biased outcomes. Education and training are also vital in combating bias in AI design. Raising awareness among AI practitioners about the potential for bias and equipping them with the tools to identify and mitigate it are crucial steps in creating ethical AI systems. Curricula that include ethics and bias in AI, as well as interdisciplinary collaboration with fields such as social sciences and ethics, can provide valuable insights into the societal impact of AI technologies. The regulatory landscape also plays a significant role in addressing bias in AI design. Governments and regulatory bodies are increasingly recognizing the need for guidelines and standards that ensure AI systems are developed and deployed ethically. For example, the European Commission has proposed regulations that emphasize transparency, accountability, and fairness in AI systems. Such regulations can compel organizations to adopt best practices in AI design and foster an environment where ethical considerations are prioritized. Human-centered AI design demands a commitment to understanding and addressing human biases. As AI continues to evolve and integrate into various aspects of society, the consequences of biased AI systems can have far-reaching implications. By recognizing the sources and impacts of bias, AI designers can take proactive steps to create systems that are not only technologically advanced, but also equitable and just. This approach not only enhances the effectiveness of AI systems, but also ensures that they serve the diverse needs of society. As AI becomes an integral part of human teams, fostering collaborative innovation between humans and machines necessitates a deep understanding of human bias and a steadfast commitment to ethical AI design. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.